In this video, we're going to continue our work in sections 13.3 and 13.4. In this example, we're going to look at example 3, where we actually compute a cross product of two vectors. All right, so let's get started. So we're told let u be the vector I plus 2j, and v be the vector negative I plus 2j plus k. Find u cross v and v cross u, and draw them on the picture or the diagram provided. All right, so let's go ahead and work out these cross products. So let's first take a look at u cross v. So we're going to compute the determinant of the matrix ijk, 1, 2, 0. Notice there's no k component, so that's as if we have 0 k. And then for v, we have -1, 2, and 1. All right, so recall we decorate here with a plus, minus, plus. And so to compute this determinant, we can look at that first row and column. So we have I multiplied by 2 times 1 minus 0. So 2 times 1 minus 0 times 2. And looking at that next row and column. So now we have minus j times 1 minus 0 times -1. And then plus, crossing out that first row and last column, now we get 1 times 2 minus 2 times -1. And that is the k component. So now if we multiply out here, we get 2 minus 0 is just 2, so we get 2i minus, we have 1 minus 0, so that would just be minus 1j. And then that final component here, we get 2 minus -2, so that would be 2 plus 2, which is 4. So we have plus 4k. So let's go ahead and draw that on our diagram. And we see that conveniently the point 2, -1, 4 is labeled here. And we see that that is our cross product. So here is where our cross product is. So now let's observe, how does the cross product, this vector here, u cross v, how does that compare to our two vectors u and v? Well, it turns out, and we can see this on the diagram, that this cross product is perpendicular to both u and v. So now let's take a look at then the cross product v cross u. So we can set up that determinant again, I, j, k. Now we have -1, 2, 1 first, because we're looking at v first, and then w, and then just u, which is 1, 2, 0. All right, so let's go ahead and compute that determinant. So we have I times the products 2 times 0 minus 2 times 1 plus, remember that negative sign, negative j times -1 times 0 minus 1 times 1, then plus k times -1 times 0 minus 1 times 1. All right, so multiplying that out, we get I times 2 oh, careful of our signs here. So we actually get 2 times 0 minus 2. So we just get I times -2, or -2i. And we get minus j, and that just becomes 0 minus 1. So that becomes -j times -1, which is just plus j. And then finally, we get in the k component, and it looks like there's a little bit of an error here. Hope you caught it. We actually get -1 times 2 minus 1 times 2. So it becomes -2 minus -2, or minus 2 rather, which gives us -4. So we should have -4k. All right, so let's go ahead and draw the picture of this cross product. So we have -2, 1, -4. And we see that that's also drawn conveniently on our diagram. So the vector that is the cross product v cross w is the vector that points in the opposite direction as u cross v. Notice also that this cross product is perpendicular to v and u. So what's really awesome is that, as we can see here in this geometric example, is that the cross product is a vector that's perpendicular to our two vectors we start with. And so in the next sections or the next videos, we're going to see how to make sense of which direction each cross product is located. So we can make sense of why u cross v should be the vector up here and why v cross w is the vector down here. So it's something called the right-hand rule. You might have heard it before, but we'll learn about it more in our class together. Thanks for watching.